Hello student, today we are starting quadratic equation. In this quadratic equation, first we are going to see the definition of quadratic, right? There is one term that's called the expression and the equation. Also there is a term that's known as identity that we have to see. Identity, right? That we have to also see this identity and its roots of the quadratic equation, right? Let's start the topic, right? First we are starting with the terminology that's known as polynomials. The polynomials is a mathematical expression involving the sum of the power of one or more variable multiplied by the coefficients. These an, like if there is an minus 1, a2, a1, a0, these are known as coefficients. The coefficients are known as, this is coefficient of an is coefficient of x to the power n, a2 is coefficient of x square, a1 is coefficient of x, and a0 is known as the constant term, right? And in this expression, right, the degree term is also used. Degree means the power of polynomial. In this, the power, the highest degree on this, the value of n, right? If n is given as 5, so the polynomial of degree 5. If it is 3, then this is known as polynomial of degree 3. And this is the special case, this is known as 2, right? A special case when this is known as 2, so this is known as quadratic. The polynomial of degree 2 is known as quadratic. Now, so we know that the polynomial of degree 2 is known as quadratic, is in the form of ax square plus bx plus c, right? Where a is the coefficient of x square, b is the coefficient of x, and c is the constant term, where a, b, c, these terms a, b, c, the coefficient may be real or complex, right? This may be real number or complex number. Complex number is denoted by this I, that's under root of minus 1. This I is known as the iota, right? That in complex number we have to study this term, right? But we have to remember a must not be equal to 0. The coefficient of x square must not be equal to 0. If a is equal to 0, so this quadratic will convert it into linear, and then one root of this will be tending towards infinity, is goes to infinity, right? So a must not be equal to 0. This is the quadratic, right? Expression means we are just representing this as x square plus 3x plus 9. We can take this as y is equal to this, right? Like x square plus 3x plus 9, or this y you can write this as fx, function of x. We have already seen the function, the variable is x, and this you are getting fx after putting the values of x. So the coefficient in these cases are, right, root 2, minus 9, and root 7. These are the coefficient of x square, x, and constant term, as well as 2i, 2 plus 3i, 5, right? These are the coefficients of x square, x, and constant term, right? So this is known as quadratic expression. But in the expression, if you have to change this or choose the term expression or equation, so you have to careful. If I'm saying this is equation, so you have to equate this quadratic with some constant or 0, right? Again, this ABC may be complex or real number, right? Then this is known as quadratic equation. If you are equating this with constant or 0, this is known as quadratic equation. And if you are giving this as y is equals to ax square plus bx plus c, this is known as quadratic expression, right? And the same case identity, if I'm saying y is equals to 0 into x square plus 0 into x plus 0, right? So if the coefficient of x square 0, coefficient of x is 0 and constant term is 0, then this is known as identity. This quadratic will satisfy more than two values, right? The degree is 2, so this must satisfy only two values. But if any quadratic is satisfying more than two values, then this is known as identity. So three terminologies are there, right? First terminology is quadratic expression, second is quadratic equation, and third is identity. Now, so with the coefficients we can write the number as 2x square plus 3x plus 7 is equal to 0. This is the quadratic equation. We are equating this with 0. The coefficient could be anything. Maybe the coefficient of x would be 0 in this case. Maybe the constant term will be 0, right? So this is also known as the quadratic, right? So we are getting two values for quadratic, right? So now the roots or the 0 of the quadratic, right? Roots or the 0 of the quadratic means if alpha may be the real or the complex one, said to be the 0 or the root of the quadratic, either this is called the 0 or the root of the quadratic. If this alpha is satisfying, this ax square plus bx plus c is equal to 0, right? If alpha is satisfying this, then the quantity may be going for ax square plus bx plus c, right? Or in this case, the example if I am giving you, in this case I am giving you the example, let the number 1 and 2 is there, that satisfying the equation x square plus 3x plus 2, right? X square plus 3x plus 2 means if I'll put the value x is equal to 1, so this will be 1 square minus 3 plus 2, right? 2 plus 1 will be 3, 3 minus 3 will be 0, so this is satisfying there, right? Similarly, if I'm going for the second value 2, then again 2 is satisfying there. So 1 and 2 are the roots or the 0 of this quadratic equation, right? So Sridharacharya has given the formula for quadratic equation. After that, this is known as Pale's theorem, right? The quadratic ax square plus bx plus c, right? Then the value of x will be minus b plus minus under root of b square minus 4ac by 2a. This b square minus 4ac is known as d, the discriminant. B square minus 4ac is known as the discriminant, right? Then the value of x will be minus b plus minus root d by 2a. Sridharacharya has given this formula in 326 BC. Let's see the proof of this, how to get this value as roots. If alpha is the root, obviously this must satisfy the equation a alpha square plus b alpha plus c is equal to 0, right? Obviously a is not equal to 0, so we can multiply both sides by 4a. See the calculation part only. 4a square alpha square, we can rewrite this as 2a alpha the whole square plus 2ab we have to write. So if I'm assuming this is a and this is b, so I have to add b square both sides, then it will be the completing square form. So this 2a alpha plus b the whole square is equal to b square minus 4ac, and we'll get the value of alpha as minus b plus minus, but the condition is a is not equal to 0, then only we are saying this. Or we can rewrite this as minus b plus minus under root of d by 2a. First value you will get for plus and second value you will get for minus. Because the degree is 2, 100% will get two values, one is for plus and other is for minus, right? So we have to remember the things, right? Quadratic equation have two roots, may be real or complex, right? Complex, as I said, there will be under root of -1, that is iota square. We don't have value if we are squaring this, so we are getting I square is equal to -1, right? And with the real number, we know that it's not possible. We will get the square of any number as negative. So this is known as the complex number, right? Maybe both the roots will be distinct or real, right? If both the roots are equal, right, that is known as repeated roots or double root of the equation. And this repeated root, you have to remember this because d is equal to, in that case, right, repeated root d is equal to 0, then we'll apply the formula. So we are getting the roots are minus b by 2a. Remember this, if I am asking x minus 2 the whole square is equal to 0, right? X minus 2 whole square is equal to 0 is given. So this having roots 2 comma 2, because this having two roots, that's the reason we have to write down 2 comma 2 in this case. Now we are going to solve few examples for this, right? Like the first example is given 7 to the power 1 plus x, and then we have to solve this. Is this a quadratic? So we are not able to say this is a quadratic or not, but if I'll rewrite this, then this will be converted into quadratic. Or we can say if 7 to the power x we are assuming as t, right, then this will be converted into 7t square minus 50t plus 7 is equal to 0. We can factorize. One of the method for quadratic is we can also factorize this if we are able to factorize, right? So after factorization, I'm getting two values, t is equal to 1 by 7 and 7. This we can equate with 7 to the power x, and with 7 to the power x we are getting one value as 1 and other value as -1, because this is given 7 to the power -1, that's -1 and 1, right? Two values we are getting, right? The solution set for this equation is two values -1 and 1, right? Next example, like if this is given, how to solve this? Just you have to see the pattern of this equation. This is not quadratic now, but we can convert this into quadratic if we are assuming one as t, right? You're getting the second as 1 by t because both are reciprocal to each other, so easily we'll get this number, right? Now the only part you have to solve this carefully, right? Then you will get two values of t, one is half and other is 2, but the t was under root of x upon x minus 3, solving both the equation for 2 and half, right? You have to solve till last, otherwise maybe the values may satisfy or may not satisfy. So you are getting values of x as -1 and 4, right? But we have to verify this -1 and 4, are we getting both the values as the real values or not, right? -1 and 4. Now for the second case, if it is given in the form of twice of x plus 1 by x the whole square minus 7 into x plus 1 by x plus 5 is equal to 0. Look into this. X plus 1 by x again we have taken as t, then getting two values, right? Solve one by one, right? Look, first value what we are getting already we have seen in the last question, right? But the second value is some strange value, right? Second equation. The second equation what we are getting is x is equal to 1 plus minus under root of 1 minus, so this is under root of -3, right? Up to 10th we have not studied this, but now we have to carefully, we can write this as I under root of 3, right? So we are getting this value, x is equal to 2.5, and at last I am getting x is equal to 1 plus minus I root 3 by 2, where I square is equal to minus 1. So already we have seen like 4 values are there. In this we know that these two are real and these two are complex number, right? If I is coming, this will be complex number. Now you can see this question again. The trick is, the tips for this is, the coefficient of x to the power 4 and constant term is same, coefficient of x cube and x is same. So when you will divide this by x square, since x is not equal to 0, right? X is not equal to 0 means x is equal to 0 is not satisfying the equation. So when we will divide this by x square, right, what we are getting, just convert this into quadratic, or we are able to convert this into quadratic. This is x square plus 1 by x square, and this is x plus 1 by x. We know that if I want to write this x plus 1 by x the whole square, right, this is nothing but x square plus 1 by x square plus 2, right? So x square plus 1 by x square, when I'll transfer this, I'm getting a quadratic equation, a simplest form. If x plus 1 by x is y, obviously converting this into the equation, and now again you have to solve, right? But you have to be careful, right? In both the case you have to see the numbers are coming as real or imaginary or irrationals, right? In this case, first we are just getting the same answer, right, half and 2, but in the second case what we are getting is the irrational roots, minus 3 plus minus root 5 by 2. So 2 values are rational numbers and 2 are irrationals. So with the different examples we can understand how to solve the basic quadratic equation. Now we are going for nature of roots and its application, right? How to use this nature of roots and how to go for the application part of this, right? What is the meaning of nature of roots? See, nature of roots means we have already seen that b square minus 4ac. This is known as discriminant of the quadratic equation, usually denoted by the symbol del or d, the capital D, right? And this d is in the formula of quadratic, this d is coming in under root. So if d is negative, so under root will be, right, not under root of negative will be not real, so this will be imaginary, right? If d is positive, so obviously the roots will be real, right? And if d is equal to 0, we have seen that the roots will be same. So the important terminology in this case is a, b, c are real, right? The most important part is a, b, c are real number. For that only we are going ahead, right? Then, and del or d greater than 0, then alpha and beta are the roots, alpha and beta are the roots that are real and distinct. Case first, right? D greater than 0, d is equal to 0. We've already seen that both the roots are real and equal. Why? Because a, b, c are given as the real values, right? And if del is less than 0, d is less than 0, b square minus 4ac is less than 0, then 100% roots will be complex and conjugate to each other. What is the meaning of conjugate? If one root is 2 plus 3i, so after seeing this root, 100% you can say that the second root will be 2 minus 3i. This is called conjugate to each other. This condition is true only if a, b, c are real, right? These three number belongs to real number, then only we can say this is true. Right? And in these portion, right, if we'll go for A, B, C are rational, right, the last one A, B, C were real, right, inside the real we are going for A, B, C are rational number, right. If A, B, C are rational, del is equal to 0, alpha and beta are the rational roots, because A, B, C rational, so rational upon rational will be rational. But D greater than 0 and the formula is minus B plus minus root D upon 2A. So this value will be rational or irrational depends on D. If D greater than 0 and perfect square, under root of perfect square will be integer only, right, under root of any perfect square will be integer only or the rational number only, then alpha and beta will be rational and distinct in this case. But if I'm saying del is greater than 0 but not a perfect square, right, this is one of the best case again. If this is not a perfect square, then 100% alpha and beta are irrational and distinct. Again, the roots will be in conjugate surds, means if one root is 2 plus root 3, then other will be the conjugate means. Very good, I guess everyone is getting this. 2 minus under root of 3. If one root is 2 plus root 3, other must be 2 minus root 3. This is the case for irrational roots, right? And in the case of when del is less than 0, alpha and beta are imaginary, then previous case was there, the same case you have to apply. If one root is 2 plus 3i, other root must be 2 minus 3i, right? That case will be same there only, right? So let's see the example for this. Like 4x square minus 20x plus 25, the roots, right? The roots will be real, imaginary, rational, irrational. It depends on D only. Since in this case A, B, C are integers, right? A is 4, B is minus 20, C is 25, and discriminant of this is coming as 0. So what case? If D is equal to 0 means both the roots are equal, right? And A, B, C are rational, so this must be rational roots as well as the equal roots, right? Prove that the equation 2x square minus 6x plus 7 has no real roots. See, if this having real roots or not real roots, it depends on the discriminant of this. So let's see, ABC given, discriminant is less than 0. Discriminant less than 0 means roots are not real, right? But one of the best example is this one, right? X minus a, x minus b plus is equal to h square. Prove that the roots are real. Look into this, right? First we have to write it down in the form of ax square plus bx plus c, right? Ax square plus bx plus c, this a is 1, b is minus of a plus b, c is ab minus h square, right? So the discriminant is a plus b the whole square minus 4 of this, right? When we'll solve this only, a plus b the whole square minus 4ab, I know the formula for this will be a minus b the whole square plus 4h square, right? So we know that both the quantities, right, both the quantities are whole square term, and sum of whole square term is always positive. Rather, maybe it's possible both are equal to 0. If both are equal to 0, then a is equal to b and h is equal to 0. So if h is equal to 0, both the roots will be a and a, right? But in that case also we are getting real roots. So overall I can say this having real roots, right? One more example, right? To realize this, when we have to solve for any quadratic, first we have to write it down in the form of ax square plus bx plus c. Then only we'll get the value of a, b and c. right? So if I'm getting the values of a, b and c, so b square minus 4ac, right? If this having equal roots, so del is equal to 0, d is equal to 0, and in this case you can see directly this b square minus 4 is equal to 0, and you are getting value of m as the factorize. You can factorize this as m is equal to 3 or 5, right? So more of the examples are there, right? You can try this question, right? You can think like the roots are equal in this case, then you have to prove that or show that either a is equal to 0 or a cube plus b cube plus c cube is equal to 3abc, right? Next class will go for sum and product of the roots, right? Thank you for today.